Alright, 5.4 exponential and logarithmic function. So for the learning outcomes for today is state the domain and range for an exponential functions. An exponential function with the base a is a function of the form of fx equals to a to the power of x, where a is the base, x is exponent, where a and x are real numbers such that a greater than 0 and a cannot equals to 1. The following are examples of the exponential functions. A fx equals 3 to the power of 2x, b gx equals to 1 over 3 to the power of x. So the first a, we can see that a is greater than 1, and b, a is between 0 and 1. Exponential function graph. Okay, we consider exponential functions into two types as below. First, we have fx equal to a to the power of x, where x is real and a greater than 1. And b, we have fx equal to ax when x is real and base is between 0 and 1. Properties of exponential functions. So look at the characteristic of exponential function. Okay, this is the first graph. Okay, right. So when a greater than 1, so the domain, you can see from here, the domain always a real number from negative to infinity to infinity. How about the range? So from this graph, we see that y always positive, which is y greater than 0 or 0 to infinity. How about the y-intercept? So this graph intercept at y, so meaning at 0, y1. And what happens to when x approaches to infinity? When x goes to infinity, at the same time y goes to positive infinity. Horizontal asymptote, when x goes to the negative infinity, approaching to negative infinity, so at the same time y approaches to 0. And horizontal asymptote also y equals to 0. Okay, now we move to when base between 0 and 1, for the domain, still real number from negative infinity to infinity. The range also 0 to 1, y greater than 0. And how about y-intercept? Still at 0, y1. But when x goes to positive infinity, we can see that when x goes to positive infinity, y approaching to 0. When x goes to negative infinity, at the same time, y approaches to positive infinity. And y equals to 0 also is horizontal asymptote. Okay, now we try to sketch exponential function a greater than 1. Okay, let's say you have fx equal to a to the power of x, where a greater than 1. Okay, first thing that what must you do is we must know what is x, what is y, what is shape, and what is intercept, y-intercept. Okay, for x meaning we look at the exponent there. So when this positive, when this one is positive, so we put here positive. And y we look at in front here. So this is positive, so I put here positive. How about the shape? Okay, the shape we get from x positive, y positive, so the shape is like this. Okay, all right, so from here this graph have intercept at y at 0, y what, so you just substitute at 0, y equals to 8 power 0, we get 1, so intercept at 1. Okay, so the shape of the graph, when positive, x positive, y positive, you get shape like that. So this one you get the graph of exponential function. Okay, fx equals to 2 to the power of x. Okay, for x here is positive, for y is positive, correct? And the shape is like this. Alright, positive, positive, x positive, y positive. So for y-intercept, you get x 0, so y equals to 2 power 0, which is 1. Okay, from here we can say that the graph is like this, and then intercept at 1. So how about the domain? The domain is from negative infinity to infinity, so all x are defined. And then for range, y greater than 0 or 0 to infinity. Okay, we look at a second type for a greater than 0. Let's say we have x negative here, y positive here, and the shape is like this. Okay, shape is like this, x negative, y positive. So this graph have intercept at 0, y you get a power 0, also you get 1. So intercept here at 1, so the graph is like this. Okay, after that you can find the domain and range. Okay, let's try this example. So we have, this is x negative here, correct? This is positive, correct? And then a greater than 1, which is 5. So the shape, we can see that x negative on this left hand side, y positive here, so the shape is like this. And then when x 0, get y 1. Okay, so the graph is like this. And then from here we can see the domain negative infinity infinity, and the range is 0 to infinity. Okay, look at another graph. Fx equals to negative a power x. Okay, from this graph we can see that a is positive, x is positive, y is negative. Alright, so when x is positive here, y negative, so the graph is like this. And then we find y-intercept at 0, so y is negative a power 0, which is negative 1. So y-intercept at y negative 1. So the basic graph is like this. Alright? Okay, so this is negative 1 here. Intercept at negative 1. Okay, for this graph, fx equals to negative 7x power 1. So this one, look at this x is positive, y is negative, and then the shape of this graph is like this. Okay, x positive, y positive, then x is 0, y equals to negative 7, 0 plus 1, we have negative 7. So y-intercept at negative 7. So we have x positive, y negative, so the shape is like this. So from here we can say that the domain is negative infinity infinity, or real number, and range is negative infinity, comma 0. Alright, the next exponential function, fx equals to negative a to the power of negative x. So from this part, you can see that this is negative x, so this is x value is negative, and y is also negative. So the shape of this graph is like this when x is 0, y 1, x negative, y negative. So the shape is like this. Okay. Alright, next example. This is x negative, y negative. The shape is like this, and then x0, y equals to negative 0 plus 2, you get negative 9. So from here you can sketch the graph like this, and then the domain is negative infinity infinity, and the range is negative infinity comma 0, or we can write y less than 0. Alright, sketch the following graph of fx, hence find the domain and range of fx. Okay, for the first one, we see that this is positive, positive, so we put here positive, positive. The shape of the graph, positive, is like this. Okay, y-intercept at 0, y equals to e power 0 is 1. So the shape of the graph here, so like this. So this is 1. Okay, the domain is negative infinity, infinity. How about the range? 0 to infinity. Alright, next example, fx equals to e to the power of negative 5x. This is negative, this is positive, and the shape is negative, y positive, so like this. Y-intercept at 0, y equals to e power 0, which is 1. So the graph is like this. This is 1. So negative infinity, infinity for the domain, and the range is 0 to infinity. Okay, see fx equals to negative e to the power negative 2x. So we can see that x is negative, y is negative. So the shape is like this. So x0, y negative 1. So y negative 1. So the shape is like this. So the domain is negative infinity to infinity, which is real number. So the range is from negative infinity, comma 0, open. Okay, for dy equals to 3 to the power of x plus 2, you can see that x positive, y positive, so the shape is like this. So x0, y 9, so 9 for y. Get the shape, and the domain is real, and the range is 0 to infinity. Fx equals to 2 to the 2 power x plus 1. So from here we can see that we have y1 here. So this is positive, positive, so x positive, y positive, and then the shape is like this. Y-intercept at 0, y equals to 2 power 0 plus 1, which is 2. Alright, so we have a line here. This is y1. So, and the shape of the graph, this graph intersect at 2 here, 2. So the basic graph is like this. So intersect at 2. Okay, so the domain is, you can see the domain negative infinity, infinity. How about the range? So the graph is shift 1 unit from x-axis, you get 1 to infinity, or y greater than 1. Okay, please take note that to sketch exponential function, make sure a greater than 1. If a is between 0 and 1, the base must change first. For example, fx equals to 1 over 2 to the power of x, so change it into 2 to the power of negative x. Fx equals to 1 over 3 to the power of x minus 1. Okay, this question you must change into this form. 3 to the power of negative x here. Okay, you change it into this and minus 1. And then after that, you make x is negative, y is positive. So the shape of the graph is x negative, y positive is like this. And then y-intercept is x 0, y equals to 1 over 3 power 0, 1 minus 1 is 0. So we have y negative 1, y negative 1, and then intercept at 0, 0. So the graph is like this. Okay, here is 0, 0. So the domain is negative infinity, infinity, and the range is negative 1, infinity. Okay, try this. Sketch the following graph of fx, hence find the domain and range of fx. A, fx equals to e to the power of x plus 2, and b, fx equals to 2 minus e to the power of negative 3x. So this is for your homework. Okay, all right.